Okay, if I put this relation into a table form, I have 4x 6y, 0x 3y, and 1x 4y. When I graph it, 4 6 is 4 to the right and up 6, 0 3, 0x means I don't move right or left at all, but I go up 3, positive 3 for y, and 1 4, 1 to the right and up 4. The domain would be the set of all x coordinates, 0, 1, and 4. If you wrote 4, 0, 1 because you took them straight from the table, that's also correct. I just prefer to put mine in ascending order. The range would be the set of all outputs or y values, 3, 4, 6 if I list them in ascending order. So that's domain and range for this relation, this set of ordered pairs. And here's an example of why we call this a relation. I just paused for a minute to try to come up with a good real-world example here. Let's say you've got a piggy bank and you put dollar bills in your piggy bank to save money. When you first start saving money, maybe at time 0, maybe you have $3 that you put in the piggy bank to start your savings. And then after 1 week, maybe you put an additional dollar in. So after 1 week, now you have $4. And after 4 weeks, maybe you by the end of 4 weeks, maybe you had a couple extra dollars, so you're up to $6 in the piggy bank. So you see how these ordered pairs could represent some kind of a relationship, like the weeks that you've been saving and the amount of dollars that you saved. So it's a relation. We call it a relation, but it's really it's a relationship between what the x or the inputs represent and what the y or the outputs represent. Here's the most important new vocabulary word, function. If each value of the domain is paired with 1 and 1, if each value of the domain is paired with 1 and only one value of the range, then the relation is a function. The two examples we just looked at are functions, so now let me prove that to you. If I go back to the first example we did, 0 is paired with 0, like that. 2 is paired with 1. 3 is paired with 5. Remember, that was because I put them in ascending order. They're not aligned like they would be otherwise, but it's fine. 4 is paired with 2. So this could be, I go on a diet and how many pounds I lose each week. So when I start my diet at 0 weeks on the diet, I lost 0 pounds because I haven't lost anything immediately when I start. But after 2 weeks, maybe I lost 1 pound. After 3 weeks, maybe I lost 5 more pounds. And then after 4 weeks, maybe I lost 2 pounds in week 4. The reason it's a function is because for any number of weeks that I've been dieting, I should lose a specific number of pounds. If on week 3 I lost 5 pounds and 8 pounds, that wouldn't make any sense. I either lost 5 pounds or I lost 8 pounds. I can't lose 5 and lose 8. So if there's one output value for every input value, if for every input there's one and only one output, then you have a function. Here's another example of a function. Because the 0 pairs with the 3, the 1 pairs with the 4, and the input of 4 pairs with the output of 6. And so again, for every input, there's one and only one output. Now let's look at this relation, 5 7, 2 2, 6 0, and 5 3. First I'm going to put them in the table, 5 7, 2 2, 6 0, and 5 3. 5 7 is right here. That's unfortunate, glitch. 5 7, 2 2, 6 0 would be on the x-axis, and 5 3. Now if I were to list, I thought I had a prompt for that, apparently not. If I were to list the domain and the range, the domain would be 5 2 6 5. So I've got a 2, a 5, and a 6 as inputs. I know that there are 2 5s, but if I have a 5 in my set, I have a 5 in my set. I don't need to list it twice. the range, the output values are 0, 2, 3, and 7. 0, 2, 3, and 7. The input of 2 is paired with an output of 2, so that maps there. The input of 5 is paired to the 7 and to the 3. So this input of 5 gives you a 3 and a 7. The input of 6 maps to an output of 0. So this is not a function, because you can't have an input like 5 mapping to two different values of two different outputs, two different values of the range. And just to bring it back to that dieting example, after 5 weeks of dieting, I can't have lost 3 pounds and 7 pounds. I either lost 3 pounds or I lost 7 pounds. You can't have one input like 5 weeks of dieting and then two outputs. You can only have one possible output for each input value. And there's other ways of, we're going to see other ways of determining whether something's a function or not. But that's one of them, mapping the domain to the range and see if you have any input values going to more than one output value. The other way is called a vertical line test. If you visualize a vertical line that moves left to right through the coordinate plane, if that vertical line ever intersects the graph or the relation in more than one point, then the relation is not a function. And I'll just go back to the last example that we just did to show you what I mean. If I make let me get a different color here first of all. If I have a vertical line right here, it intersects no points in my relation. If I have a vertical line here, it intersects 1 point. That's fine. It can intersect 1 point or no points. But as soon as it intersects more than 1 point, then it's not a function. Because we've failed that test of having the input mapped to one and only one value of the output. So if you can draw a vertical line that goes through more than 1 point, you've ruled out that it's a function. It cannot be a function.